Okay, once we have the mass flow, we can find the volumetric flow by dividing the mass flow by density, and we can plot that just as we did the mass flow, which is L, which is the length divided into 26 intervals, and then the volumetric flow, which will also be divided into 26 intervals, because we'll be taking the max of the max volumetric flow in each interval. And with the variables that we've created, we can also plot other things such as the path of an atom as it flows through the tube, and we basically do this by just plotting the x and y coordinates and just making sure that they correlate, which is what we did by sorting both of these by atom number in our previous plot. And so with this one, we're just finding the path of the first atom as it flows through the tube. And we can also find velocity distribution as a function of x. And we do this by, we're going to do this by just finding the mean velocity, which is basically the this would take the average velocity from each row, and so that would basically take the average velocity in 26 intervals, and this would coincide with L, which is the length of the tube divided into 26 intervals. And once we plot all of this, the last one is a constant line, and this basically shows that velocity is increasing as it flows through the tube. So for people who want to create new filtration systems, I guess the longer the tube, the better. Figure 7, this is the path of atom 1 as it flows through the tube, and it goes like this because like it leaves here and then re-enters over there, because the atoms are actually leaving the tube and then re-entering. Figure 6 will be the volumetric flow, which basically mimics the velocity as a straight line, and this basically means that the volumetric flow is also increasing as distance is increasing. So the more times that the atoms go through, or the more it goes through the tube, the more volume flows. It increases as a constant, and we see the same thing with mass flow. It increases as a constant. And then with this one, this is the pressure as a function of distance of all 300 atoms, and then we have the slope of all of those combined, which is fairly straight. So the pressure as a function of time is basically constant. And with this one, we have just the first and last atom. We're also plotting the pressure as a function of distance, and the black line is basically the slope. So for the first atom, we have the pressure slightly increasing as it goes through the tube, and for the last atom, we have it slightly decreasing as it goes through the tube. Figure 2, this is the pressure as a function of time step. This is actually the mean pressures. So the average pressure is between 3 and 3.11 as a function of time step, so there's not much fluctuation there. And then this one is all 300 atoms, well, the pressures of the atoms as a function of time step, or as a function of time. And they're all over the place, but as you've seen with the previous example or the previous graph, the mean is right between here, and then also the average. Well, yeah, the mean is the average. It is right between here, and it's pretty constant. Okay, so for the first graph, but the last one that we saw, it had a bunch of, just lines everywhere. It's pretty hard to decipher it. So if we wanted to analyze the pressure of one atom as a function of time step, then we can actually just go here. We want all rows as the first column. That'll give us all of the They'll basically give us all of the spots for the first atom, and then this will give us all of the pressure for the first atom. And then when we plot that, it'll basically give us the pressure as a function of time for the first atom, and this is basically what that shows. Also with this one, when we plotted the path of an atom as it flows through the tube, we can also manipulate this one. So if we wanted to follow the path of the second atom, then we can just change the column to the second column. And this is our new one. So this one, okay. Okay, so this one is actually traveling backwards. And then this one is traveling backwards. So this one actually has a negative velocity. Okay, and if we just wanted to find the paths of all of the atoms, then we'll just get rid of that. And this will actually show us 300 lines. Yeah, I really can't decipher anything from that, so I would say it's better to either do each individual one or find the mean and break it down into intervals so you can absorb the basically the y coordinate as a function of distance. Yeah, you'll be able to absorb more data from that. And that's basically all. Thanks for watching.